How does the Enigma machine work, and how can we crack it? The Enigma machine, used by the German army, consisted of a keyboard that the operator typed his message on, a plug board used to configure the machine by transposing letters, 3 rotors that could rotate after each key press, and a lamp board which showed the encoded letter. At any one time there was only one electrical path through the machine for each letter pressed. When a letter was pressed, say A, the wire from the A on the keyboard connected to the A on the plug board. Here it might get changed to a P by a wire connecting P to A. From here it went through the entry point of the first rotor. This might change the P to an R. From here it went to the second rotor, which might change it to Q. From here it went to the third rotor, which might change it to S. From here it went to the reflector, which might change the letter to a B. From here it went to the third rotor again. This might change the B to C. And from here it went to the second rotor, which might change it to D. And from here it went to the third rotor, which might change it to E. It would then pass through the entry rotor to the plug board, where the E might be connected to F. And finally, the F light would turn on. The rightmost rotor would then move on one position, changing the wiring for every character on the keyboard. So long as the rotors were turned back to their start positions, then when the F was pressed, the electricity would flow through the machine in the reverse direction and the A light would light up, in effect decoding the message. There are a number of features of this system that were used by the cryptographers trying to crack it. Firstly, the reflector wheel could never return the electric current down the same route. The electricity had arrived by this route and could not return the same way, as there would not have been a circuit. This meant that a letter could never be encoded as itself. This problem could have been resolved by doubling the number of connections on each wheel, one for the outgoing path and one for the incoming, but this would have increased the cost and complexity of the machine. Secondly, the middle rotor did not turn over except when the right rotor reached a certain letter. This means that for up to 26 characters in a message, only the right rotor is moving. As we have seen, A becomes F and F becomes A, with the rotors in the same position. This is so encoding and decoding can be done easily. In other machines, not the Enigma, decoding would require a switch to be moved, but on the Enigma this did not happen. Everything was kept as simple as possible for the operator. Finally, the operator did not understand the need for some of the rules that were needed to ensure security. Using common phrases was one of them. Many SS messages ended with the words Heil Hitler. At 6 o'clock in the morning, many stations reported the weather.
Wettervorhersage
is German for weather forecast and appeared in many messages. One operator in the Western Desert, that's Libya or Egypt, sent
keine besonderen Ereignisse,
which is best translated as nothing to report. It was still sunny and hot. This gives us a way to crack it. The words
keine besonderen Ereignisse
are our crib. These words we think are in the message, because it comes from our friend in North Africa. Here is some encrypted text. It comes from an example in Wikipedia. We believe
keine besonderen Ereignisse
is within it. Let's look at the first 6 positions. In the first position, N and S don't match, so this crib cannot be in this position. In the second position, S matches a different S, so this can't be the position. In the third position, E and I match, so this can't be the position. In the fourth position, nothing matches, so this could be the position. We've got one. In the fifth position, O, E and S match, so it can't be this position. In the sixth position, S matches, so it can't be this. In the seventh position, N, S and E match, so this can't be the position either. With only one match in 7 positions, this gives us the confidence that position 4 is not only correct, but that the phrase is in this code. We can see that only if the text starts at position 4 is it possible for the crib
keine besonderen Ereignisse
to be in this text. Now, this bit is hard. Let's look at how to crack it. Look at positions 18, 21, 22, 24 and 28. They describe a loop. In position 18, N is changed to H. In position 22, H is changed to I. In position 21, I goes to E. In position 28, E goes to S. And in position 24, S goes to N. Remember, N is where we started. Imagine an array of 28 rotors where each rotor is offset by 1 from its neighbour. If you can't imagine it, it looks like a bomb. We put a current in at N on rotor 18 and it comes out of the rotor. And we put it into rotor 22 and take the output from that and send it to rotor 21 and then 28 and then 24. Finally, we check the output from rotor 24 and see if it is coming out the same position as the input to 18. It is unlikely that it does, but if it does, we have found a route through the rotors that could have made the message. Now, we put the current in at N, but the way the bomb is designed with its Welshman diagonal board, it means if the rotors are wrong, all 26 wires will receive current. If the guess matches the plug board on the Enigma, then one wire will light up. If the rotors are right, but the plug board does not match, then 25 wires will receive current. Simple, eh? There are a couple of problems to this. First, the middle wheel will turn over somewhere during the process, but these positions are all close together, 18 to 24 being only 6 steps, so it's possible but unlikely that the middle wheel will move on. Secondly, there can be many combinations of rotor positions that satisfy this circuit or loop. Fortunately, we can increase the number of loops, which very much decreases the number of matches. Here's the diagram of the loops for our word. I've marked the loop we've been working on in red. All this information can be wired into the bomb. With the number of loops we have, and I count 9, the machine is likely to stop at only the relevant positions, assuming that the middle wheel does not move on. We have to try each of the 60 positions that the 5 available rotors can be used in. If we got it all wrong, and the text is not in position 4, or the middle wheel did turn over, then we probably won't get a solution and the run will finish with nothing found in about 10 minutes. More likely, we'll get some false options where different rotor settings result in the same result. Then, we can check it to see if the rotor settings we have found match the other letters in the message. If they do, we have cracked the settings for this network for today. Then we go on to try to crack the 50 odd networks the Germans used, each one with a separate setup for the machine. Tomorrow, we do it all over again.